So now we will discuss about stream function. So this is just a revision because after this we will use the idea of stream function and also the idea of component velocity. So what is the relationship between the stream function and the velocity and the idea of Navier-Stokes equation? So if you see a few questions about Navier-Stokes equation in previous tutorial, you will find that from the Navier-Stokes equation, normally one of the important parameter that we could get from the Navier-Stokes equation is we could get the value of velocity. So, and then from the velocity, whether we could get the resultant velocity or we could get the component velocity, okay, then we use that component velocity and so on to determine the stream function. So the stream function is actually, in simple words, I think you already learned about the stream function. So the stream function is actually the path of molecule moving from one point to another point. So for example, if you have an aerofoil here, for example, so you put this aerofoil in a wind tunnel. So and then if you use smoke generator, so and then you will have the smoke will go up there and then flow like this. So if you increase the flow, the wind, so maybe you will have a stream function. The smoke will go like this, and then it will have a vortex here, and so on and so forth. So actually, this line is called a stream function, a streamline. Okay, so and then the word function here means we try to recreate the line here by using mathematical equation. So that equation is called the stream function. So from that, okay, so and then to develop the stream function, okay, so we start with the component velocity because this is the simplest way, and then it can be validated with the real situation. So we could validate by using the idea of pitot tube, for example. And then, for example, we have a situation like this, so we put our pitot tube here. So I hope you could understand what is pitot tube. And then from the pitot tube, we could measure the pressure. So and then I think you already know how to solve using a pitot tube. So we use Bernoulli equation, we substitute the pressure difference, or we check the pressure difference, and then we could determine the velocity at this point. Okay, so and then if we get the velocity at this point, okay, so means that we know the real velocity, and then we could determine or we could validate what is the calculation or the simulation velocity in our equation. So and then when we develop our stream function or streamline, and then we could impose on the real line here, and then we could know whether our calculation or our function, our equation for the streamline is correct or not. So then if we validate the calculation, then you could move further in your simulation to simulate another situation. So this is actually the basic idea of using the simulation and so on. So and then I think you already know about this. Okay, for example, we are focusing on two-dimensional only like this to give you some ideas about the idea of stream function. So and then we have Cochiriman equation. So from Cochiriman equation, we know that the u is equal d psi over dy, and the v is negative d psi over dx. So in previous tutorial, sometimes people ignore the value of negative because value of negative is just to show the direction, whether it is counterclockwise or clockwise. So in this tutorial, I will give you the idea of negative because at least you could know sometimes in master project, okay, in master level, you have choice. You could make your own simplification or your own assumption whether you want to use negative or not, because it is sometimes it could simplify the calculation. Okay, in this question, so I will use the idea of negative here. Okay, let's say we have the u component, mean the velocity for x component is x minus 4y, and v is negative y minus 4x. So, and then we know the relationship between the stream function. So the psi here is the stream function. So the psi here is the stream function. So the relation is u equal d psi dy, and v is minus d psi dx. Okay, so and then I think everybody knows when we see the differential terms here, and then we need to do the integration to get the full equation. However, you must know that we only have, so the u here is the x axis and the v here is the y axis. So means that you need to use both of these equation to write your own, to write the final stream function. You cannot just use one. Okay, so we do part by part. So we go for the x-axis first. So let's say we assume that d psi is equal u dy. So and then we substitute the value of u here. So we have dy. And then we integrate both sides here. So and then we will get the integration of d psi. So we get the terms of psi. And the integration of x minus 4y dy. So we get xy minus 4y squared over 2. So we simplify it as negative 2y squared. And then because we did the integration in terms of dy, we need to add the constant for the integration. And then the constant for the integration is, the common one is the integer. So mean it's a constant, just a number, 1, 2, 7, 3.5, and so on. And another constant that need to be added here is the constant from the x element, because we are doing the integration to dy. So means that if we have component of x, it also treated as a constant. So if you have 5 plus x plus y, so we if we differentiate it, the dy here, so the idea is everything here is equal to 0. Okay, so means that if we integrate that one, so we need to put back the value of integer here and also the constant from the x element. So this is that is the idea of this one. So and then we will have xy minus 2y squared plus v fx, mean function of x, plus c. So and then normally we assume that our stream function is start from 0, 0. So we have a psi is equal to 0, x equal to 0, and then the c is equal to 0. So now means that the c can be neglected from the equation, but this equation is actually not finished yet because we still don't know what is the value of fx. Okay, so what we need to do is, again, okay, we just revert the step, but we are focusing on the fx, okay, because we want to know what is the value of fx. Okay, so the trick is we differentiate to dx. So we have the d psi dx here, and then we have d dx for all this term. So and then if we differentiate the xy, so the y, we get the value of y. If we differentiate of okay, 2y squared, so it will become 0 because it is constant in term of y, in term of a y element. And then we need to differentiate the value of fx, so we write as d over d dx for fx. Okay. So and then we know that the term d psi dx in previous slide, okay, will give us the value of v, and the v here is equal to negative y minus 4x. So what we need to do is we replace the term of d psi dx here with the value of negative v, and it is equal to y plus 4x. Okay, now you could see that actually the negative sign is actually showing the direction. So it is okay for you to have the negative or not to have the negative sign. So and then we put here, so we have the y plus 4x equal y plus dx, and then we could cancel the value of y here. So we have 4x equal d dx fx, and then we could do the integration to get the value of x alone. So if you do the integration, the value of fx is equal to x squared. So and then we could complete the equation as you could see from the slide here. So the psi is equal to xy minus 2y squared plus 2x squared. So this is the stream function for only one streamline. Okay, so then if you have a lot of streamline, for example, you have the stream aerofoil here, you have a lot of streamline here. So each line here will give you a new equation for psi. Okay, so this is the situation if you do research about the streamline and so on. Okay, please make sure that you know each stream line will have their own stream function, because at the end here, so maybe the streamline will go straight like this one. So I mean it's back to the straight line.